Imagine two atoms floating alone in the emptiness of space, separated by darkness, silence, and unimaginable distance, and yet somehow they glow together like perfectly synchronized dancers. For decades, physicists believed this eerie quantum choreography was possible anywhere in the universe. But a shocking new discovery just shattered that idea. Atoms cannot fully synchronize their light in free space. And that tiny sentence hides a terrifying implication about reality itself. Because if atoms can't perfectly coordinate in the emptiness of the universe, then the universe may be far stranger, lonelier, and more unpredictable than we ever imagined. The story begins with a dream scientists have chased for nearly a century. The dream of perfect synchronization. Humans love synchronization. Your heartbeat syncs with your breathing. Musicians sync rhythms into symphonies. Entire cities sync their lives to clocks. But nature's most beautiful synchronization happens at the smallest scale imaginable, where atoms emit light in coordinated bursts like cosmic fireworks. This phenomenon is called soup. When atoms act together, they don't just glow, they explode with brightness. Imagine a choir singing in perfect harmony. One voice sounds small. 1,000 voices shake the walls. For years, scientists believed atoms in empty space could behave the same way. But then came the new study that flipped everything upside down. Researchers expected to confirm a long-standing assumption. Instead, they discovered a hidden rule of the universe no one saw coming. Atoms in free space cannot fully coordinate their light emission. Something invisible stops them from reaching perfect unity. And the moment physicists realized this, the question became chilling. What is preventing atoms from cooperating in the emptiness of space? Because this isn't just about light. This is about how reality communicates with itself. To understand why this discovery matters, we need to go back to the early days of quantum physics, when scientists first realized the universe behaves like a stage full of invisible conversations. Particles talk using light. They send messages across space using photons, tiny packets of energy that travel at the speed of the universe itself. Every glow, every sparkle, every star shining in the sky is a massive conversation happening between atoms and light. For decades, physicists imagined that atoms floating freely could perfectly coordinate these messages, like a group chat where everyone speaks at the same time. Perfect unity, perfect timing, perfect harmony. But the new research reveals a disturbing truth. Space itself interrupts the conversation. Yes, the emptiness of space is not truly empty, and this is where the first major reveal hits. Free space is noisy. Not noisy like sound, but noisy with quantum uncertainty. The vacuum of space is bubbling with invisible fluctuations, constantly appearing and disappearing energy fields that flicker in and out of existence. This quantum noise disrupts atomic communication. Even when atoms try to synchronize, the vacuum whispers random interference into their conversation. Suddenly, perfect coordination becomes impossible. And if this sounds abstract, here's the terrifying part. The entire universe is built on atoms communicating with light. Stars shine because of it. Technology works because of it. Even your eyes see because of it. So if atoms can't perfectly coordinate in free space, then perfect order may be impossible anywhere in the universe. But the story gets stranger, because scientists didn't just discover a limitation, they discovered a hidden advantage. When atoms are trapped inside special environments, like mirrors or cavities, they suddenly regain their ability to synchronize. It's like singers suddenly harmonizing perfectly when placed inside a concert hall. This is the second major reveal. Synchronization depends on the environment. In total isolation, atoms fail. But inside structures, they succeed. And this leads to a mind-bending realization. Structure creates cooperation. Isolation destroys it. Sound familiar? This pattern exists everywhere. Humans thrive in cities, communities, and networks. Companies thrive in ecosystems. Ideas spread through connections. And now, we know atoms followed the same rule. The universe rewards connection, but punishes isolation. And suddenly, this quantum discovery becomes more than physics. It becomes a cosmic metaphor. But we're not done yet, because this discovery unlocks something far bigger than philosophy. It unlocks the future of quantum technology, quantum computers, quantum internet, ultra-secure communication systems. They all rely on synchronized light emission. Scientists hoped free space communication would allow quantum networks across satellites and planets. But now, we know the dream is harder than expected. Space itself sabotages synchronization, meaning future quantum networks may need carefully engineered environments to function. The dream didn't die, it just became more complex. And complexity means opportunity. Because whoever solves this challenge first could control the next era of technology. Imagine a global quantum internet, immune to hacking. Imagine communication faster, safer, and more powerful than anything in history. This discovery didn't close the door, it revealed the maze behind it. And that maze leads to power. But here comes the third major reveal. The discovery hints at a deeper mystery about reality itself. Quantum physics often suggests the universe behaves like a network of relationships, rather than isolated objects. Nothing truly exists alone. Everything depends on interaction. And now we see evidence again. Even atoms struggle in isolation. Cooperation requires context. Reality may not be made of things. Reality may be made of connections. Let that sink in. The universe may not be a collection of objects floating in emptiness. It may be a web of relationships constantly influencing each other, a cosmic social network where isolation weakens existence itself. Suddenly, the phrase empty space feels misleading. Because space isn't empty. It's an ocean of invisible interactions, shaping every event in existence. This discovery also changes how we think about stars. Inside stars, atoms exist in dense environments where synchronization becomes easier. That's why stars shine so brightly. Not just because of nuclear fusion, but because atoms cooperate in crowded environments. The sun isn't just a ball of fire, it's a massive synchronized orchestra of atoms working together. And if that orchestra were scattered into empty space, the music would weaken, the brightness would fade, the harmony would break. This realization adds emotional weight to the night sky. Every star you see represents atoms, achieving what isolated atoms cannot. Unity, cooperation, harmony. The sky becomes a reminder that connection creates brilliance, and isolation dims the light. But here's the twist that makes this story unforgettable. Humans once believed the universe favored independence. Survival of the fittest, lone explorers, individual strength. But quantum physics keeps telling a different story. The universe favors cooperation. At every scale, from atoms to galaxies to civilizations, progress happens when systems connect, when information flows, when environments enable and suddenly, this physics discovery feels personal, because we live in an age obsessed with independence. Hustle alone, work alone, win alone. But the universe itself whispers a different rule. Nothing shines alone. Even atoms need the right environment to glow together. And maybe that's why this discovery resonates so deeply. It reminds us that connection is not a weakness. Connection is power, but we still haven't answered the biggest question. Why does space interfere with synchronization at all? Why would the universe build a rule that limits perfect coordination in isolation? Some physicists believe this limitation may protect cosmic stability. Perfect synchronization everywhere could cause runaway energy bursts, unpredictable radiation storms, and unstable systems. The universe may deliberately prevent perfect order to maintain balance. In other words, imperfection may be a safety mechanism. Chaos may be a stabilizer. And once again, the universe mirrors life. Too much order becomes fragile. Too much chaos becomes destructive. Balance creates resilience. This discovery hints that the universe is not trying to be perfect. It is trying to be stable, and stability often requires limits. So what does all of this mean for the future? It means quantum technology will evolve differently than expected. It means space exploration will require new engineering strategies. It means our understanding of reality just took another step forward. But most importantly, it means we have once again discovered how much we still don't know. Every time science answers a question, it opens 10 more. Every discovery reveals a deeper mystery hiding beneath it. And that's the beauty of science. The closer we look, the stranger the universe becomes. We started this story with atoms trying to synchronize their light in empty space, a tiny experiment. A small question, but it led us to a profound realization about connection, cooperation, and the hidden structure of reality. The universe is not silent. It is not empty. It is not simple. It is a web of interactions shaping everything we see and everything we are. And the next time you look at the night sky, remember these. Every star shining above you represents atoms achieving what isolated atoms cannot. Harmony through connection, brilliance through cooperation, light through the environment. And here's the cliffhanger that keeps scientists awake at night. If atoms struggle to synchronize in free space, what happens across the vast emptiness between galaxies? Could entire regions of the universe be dimmer, quieter, or stranger because of this rule? Could the structure of the cosmos itself be shaped by the limits of synchronization? We don't know yet, but we're getting closer, and the deeper we go, the more the universe feels less like a machine and more like a living network of relationships. So if this discovery fascinated you, shocked you, or made you see reality differently, make sure you like this video, subscribe to the channel, and tell us in the comments. Do you think the universe is built from objects or connections? Because the answer may change how we understand everything.